Hello everyone, thank you for joining. This is third part of video What Mobile Networks. In the previous two parts we discussed historical aspects, which were prerequisites for mobile network appearance, as well as evolution of radio resources over the time in mobile networks, where radio is our bottleneck, which affects on overall throughput of sending data. Next topic could help us to answer the question, what is inside mobile networks? A lot of us could easily think about mobile phones and base station communicating with each other over the air. But that's not the only two logical components of the network. Let's briefly look what are the other main components of the network and how they were evolving from first generation to fifth generation of mobile networks. We will talk only about mobile networks' native services delivery, voice calls, supplementary services around voice calls, like call forwarding, call waiting, conference multi-party calls, etc., packet data services, and we maybe briefly mentioned SMS service. Charging or billing systems are out of scope now. It's not about delivering services, it's about monetizing them. Services received by applications, bank apps, instant messaging, WhatsApp, Facebook, Google Maps, etc., they are provided by third parties, not by mobile network, and they use packet data service from mobile network underneath. Mobile network in this case works as analog of wire between phone and third-party resources. Such services themselves are also out of scope for now. There are three major parts, big subsystems of mobile network. Subsystems have own distinct non-overlapping functionality. We already mentioned them when discussed hierarchical tree-like structure when searching for throughput bottleneck. Now let's dive deeper. First one is user equipment, UE. UE's examples are mobile phones of any types, wireless modems, standalone or inside tablet computers, IoT devices, IoT stands for Internet of Things, and usually they are in people's users' hands. UE's main task is to access the rest of mobile network for receiving end-user services. For mobile phones, end-user services are voice calls, short messages, packet data service, which is consequently used for browsing, email, and by lots of applications installed on the phones. For wireless modems, end-user service is only packet data service, works as just entry point to Internet. For IoT devices, end-user service is to periodically send small chunks of data carrying information from sensors and other devices, for example electricity meters, temperature sensors, humidity sensors, etc. Second part of mobile network is radio access network, RAN. RAN takes care of radio connections between UEs and mobile network, starting from resource allocation, reallocation, and ending with forwarding data further to mobile network's centralized part. Before 4G, LTE, RAN consisted of two separate logical nodes: controlling node, which is the brain of RAN, handling all resources, and base stations, which are just to implement physical radio connection based on commands coming from controlling node. In 4G and in 5G, they combined functionality of mentioned two logical nodes within just one logical node. I don't know why, but with each new standard they usually come with new naming conventions and abbreviations. Just FYI, who wants to read more? In 2G, GSM, controlling node named Base Station Controller, BSC. In 3G, CDMA, it named Radio Network Controller, RNC. And base stations named Base Transceiver Station, BTS, and Node B respectively. In 4G, combined node named Evolved Node B, eNode B. In 5G, it was named gNode B. Third part of mobile network is core network, CN. CN task is to provide mobile networks native services to authorized users who preliminarily subscribed for requested services. There is a list of functions inbuilt within core network, and for simple and logical structure, such functions are implemented within separate distinct logical nodes, each covering certain functions. Several nodes connected to each other and compose network of nodes. When they communicate based on certain coordinated preliminary specified actions and rules, such network can be named distributed system. Mobile network, and especially its CN part, is a perfect example of lots of different nodes constructing distributed system. What analogical examples of distributed systems can you find in real life? Let me share an example which came to my mind. It's about simplified model of transport system using cars and trucks on roads. Sea or air transportation is out of scope. There are a lot of pieces of this system, and predefined processes are in place to make its work in an expected way. Let's look and see analogies between transport system and mobile network. Main users of this transport system are all myriad of cars, trucks, buses, together with drivers moving around, and probably with passengers inside. Let's for simplicity assume that all these cars should use visible infrastructure, which is based on paved roads, road surface markings and borders, which clearly shows which sub-resources can be potentially used while driving. Next block of involved parties helps to set up the scope of our car's use. We can think about cars appearing on our roads as chaotically moving, but in fact overall system has some governing rules, restrictions and certain procedures in place, and certain organizations helping to implement them. For example, in USA, Department of Motor Vehicles, DMV, is taking care of car licensing, using, for example, annual registration procedures and handling database of all officially registered vehicles in state, starting from storing unique VIN numbers, which assigned for each vehicle. Another Department of Licensing, DOL, helps to obtain driver license by drivers applicants, handling database of officially licensed drivers along with type of document issued for motorcycles, cars, trucks, commercial vehicles, etc. If driver wants to cross country border using a car, it required to obtain passport or equivalent document prior such trip. Department of State helps with issuing passports. If driver wants to cross the border faster and more convenient, he can uplift his border crossing document, joining trusted traveler programs like Nexus, Sentry or Global Entry, for example, to cross US border using cars, trucks. Department of Homeland Security could help to make it happen. If you want to use alternative paid toll roads, which usually save time, for example at rush hours, and usually are of better quality, you can request toll tag from government or private authorities. For example, in Seattle area of Washington State, some tolls are managed by Washington State Department of Transportation. In Dallas, Texas area, North Texas Tollway Authority, NTTA, is helping with similar task. Car insurance provided by insurance companies is telling who is authorized to drive particular car and insured while driving. All just mentioned authorities establish some databases with information what can be potentially done with registered car by drivers with certain issued documents in hands. Once the scope of use and permissions are set, drivers can move their cars to provide implement service. For example, move themselves, passengers or cargo, by moving car from one place to another. What is helping to implement service? Geographical maps, mostly replaced by GPS navigators or equivalent software on smartphones, help to find and build proper route to drive car from one point to another point. Regulating devices, traffic lights, signs, etc., allow to change one road to another one or restrict some users, for example sitting in trucks, from entering certain road while allowing others to use, etc. Help to regulate proper moving. Important thing, drivers' actions should enable traffic to be in place. Their actions are to follow all traffic rules, lights, signs, speed limits, etc. To select appropriate service, free roads or paid tolls, based on capabilities and wish. Police enforces some verification procedures on the roads to ensure rules are followed and drivers are properly licensed with car insurance in hands. International bilateral agreements between adjacent countries are to be in place to allow crossing the borders using vehicles in general. And border control agencies need to be presented to verify particular driver, passengers or cargo, if any, being eligible for crossing countries' borders. These were examples of entities helping to implement service, driving a car. Additionally, we can mention gas stations, which allow to refuel cars with gas when needed, to be able to continue service delivering when previous gas reserve was used. Passengers or cargo, if present, can be considered as main service consumers. We could find other parties which may be involved in our transport system using vehicles on their roads, like emission control centers and so on. But I think it's already more than enough to show that we have a very schematic, very structured, non-overlapped functionality distributed between several entities to deliver end-user services, passengers or cargo transportation. Why we discussed that? It was about a live example of distributed system. And mobile core network part also can be seen as such system. From the first view it looks very bulky, but if we look closer, each node within core network has its own functionality, with main goal to deliver end-user services, like voice, packet data, etc. Let's briefly look to some mobile network nodes and their functions. There will be quite a lot of nodes names and their abbreviations. No need for you to remember these abbreviations. Keep them for reference in case you plan to dig deeper into details. What's the most important is to understand main functionality of nodes by design intent. Each mobile operator should handle main subscribers database for storing unique mobile users' identities and subscribed services for each identity throughout all clients of mobile operator. Such database has different names depending on mobile network generation, but its main functionality is the similar regardless of different used names. In 1G networks, name was Home Location Register, HLR. At certain points, standards brought Home Subscriber Services, HSS name. In 5G, it transformed into User Data Function, UDF. Mobile network requires to store subscribers' identities similar to DMV with vehicles' VIN numbers. Simplified, once you signed contract with mobile operator and once you first time registered your car, identities are stored in respectful databases. That's how mobile network knows which mobile phone to deliver services later. Which service is allowed by mobile network to be delivered to particular user? Is subscriber allowed to have packet data service, call waiting, call forwarding? Can subscriber use 3G or 4G or 5G radio or make calls over Wi-Fi, etc.? That is also stored in the mentioned subscriber database. It can be compared with type of driver license, which DOL provided. If you have license for driving cars, you are not allowed to drive bikes or trucks. Another service example is international roaming. It can be allowed or restricted for subscriber. Similar to example of having or not having passport for international travel. Some mobile operators can provide different international roaming experience, for example with higher data throughput or with unlimited data plans. It can be somehow compared with having registered or not registered within trusted travel programs, making your international border crossing more convenient. Some mobile network subscribers require higher priority access to the network, for example first responders, police, emergency medical vehicles, and some other. They need to be able to receive service anytime. Even if mobile network is overloaded and may not have resources for regular subscribers, there is a possibility to have subscribers with higher priority to still access a network, and resources will be provided, for example, for them to make or receive calls. We can somehow compare priority mobile network access with using paid tools, which usually are less crowded. You may think that all such services are provided by default to all mobile network subscribers, just because you may had such experience in the past, or you didn't think about list of potentially available services. But it's not actually a case. Technically, each service from whole standardized potential list needs to be explicitly switched on or off in subscriber database for each user. There is another functionally separate mobile network database which stores certain authentication parameters to ensure that no fraudulent subscribers will receive mobile network services using the same identities as a real subscriber. Authentication is needed because financial responsibility comes with unique subscriber identity. If identification is to ensure we met Mr. Smith, Authentication is to verify that Mr. Smith is not a faked or cloned Mr. Smith. And it's done by checking does Mr. Smith know certain password to access some premises. Such password needs to be known only by two sides, by Mr. Smith and some gatekeeper to compare are they equal before allow entrance to receive a service. No one else should have access to third-party passwords. Such passwords in mobile networks are provided by authentication database. It also has different names and abbreviations throughout different mobile network generations. Authentication Center, AUC, or Authentication Function in 5G, AUCF. You can compare it with DOL database, which holds all driver license numbers. When police officer stops some driver on a road and takes driver license, he sends a request to centralized state database to verify that driver license number is the same in their system as in the document provided. If there is a mismatch, which means driver license is a faked one, therefore its holder has no right to drive a car. DL number is in our example kind of authentication password known to driver and centralized database only. And I want to strengthen here that even though verification of DL number is done by the police officer, DL number is stored in a database. That was about authentication database in mobile network. From databases moving to nodes, which are responsible for implementing, delivering services. And implementation starts with prerequisite, verification steps. Frontline core network nodes help with subscriber identification and authentication, and then checking which services are allowed. Such functionality is based on requests coming from mobile phones and information retrieved from subscriber database and authentication database. It's similarly to police officer actions, who takes DL, checks who is DL holder, identification, is DL authentic, authentication by DL number, maybe checking car insurance as well, and verifying is appropriate vehicle driven based on license information. If truck is driving while DL allows to drive motorcycle, police officer rejects service, won't allow to drive truck further. In mobile networks, such procedures are done by nodes which handle mobility management functions. These functions include two main areas: tracking of subscribers' state and tracking subscribers' location till a certain extent. Subscriber state will be properly changed internally within such node if identification and authentication were successfully verified. After that, state changes and they say subscriber is attached to the network. Historically, mobile network can be seen as having kind of two core network parts. First one is to handle voice circuit switched calls, and second one is to handle packet switched calls. Do you remember first generation mobile networks with voice service based on channel reservation? That was about first CN part. I think they are going to be history soon. They are already not in the picture in 4G and 5G networks, which are pure packet data networks, and voice services are adjusted accordingly. So I'm not concentrated on circuit switch network now and move to packet switched part. Main node handling functions on packet core side also was changing names from generation to generation, but functionality remains pretty similar. Initial name was Serving GPRS Support Node as GSN, appeared in 2G networks. With 4G LTE networks, they brought Mobile Management Entity MME name. In 5G networks, they came up with Access and Mobility Management Function, AMF. And we already discussed functions. Going next, main service of packet data CN part is to provide kind of logical pipe throughout mobile network between UE and external packet data networks, EPDNs. User data is to be sent over such pipe. By the way, in mobile networks, such pipes can be named sessions. Examples of EPDNs are Worldwide Internet, Closed Virtual Private Networks, VPN, of some organizations, special network for implementing voice calls over the packet data networks, etc. These EPDNs are logically separated from each other for security reasons. If subscriber has no subscription to reach its company's VPN, such VPN should not be reached via other EPDNs. Next question. How to reach such EPDN from UE? How to send back and forth traffic between UE and EPDN? If end user subscribed to access some EPDNs, functional node verifies and confirms subscription. After that, session management functionality and respective nodes responsible for routing user traffic via mobile network jump into picture. FYI, such node names are Gateway GPRS Support Node, GGSN, introduced in 2G networks, then later replaced by pair of Serving Gateway, SGW, and Packet Data Network Gateway, PGW, primarily in 4G networks. And in 5G supported Session Management Function, SMF, along with User Plane Function, UPF, came into picture. Such nodes are centralized, and any operator has just few of each node in its mobile network. For example, operator can use less than 10 S gateways and 10 P gateways to provide functionality for subscribers within the whole big country. Therefore, such CN nodes should be able to handle very high capacity, high load coming from thousands of subscribers at a time. When subscriber needs to send user packets through mobile network, such nodes need to be selected for subscriber among few alternatives. So in network, we have kind of pre-selected node chain between UI and EPDN. Per each subscriber, selecting node chain in CN and routing traffic through them within logical pipe named session is another service implementation functionality. Node chain selecting process may depend on some input data like geographical area, which radio node may determine traffic routing to the nearest CN nodes, or redundant ones if nearest are temporarily unavailable. It also depends on subscription and CN configuration. When subscriber plan to reach certain EPDN, some CN nodes are connected to such EPDN, while others are not. Analogically thinking, selecting node chain between UI and EPDN can be compared to GPS navigator providing route between starting and finishing points for driving, including centralized highways on the way, handling lots of cars driving. There might be service-related restrictions for selecting some nodes, similarly to a case of some roads not eligible for driving trucks, for example. So different route needs to be selected. Routing and transporting user data traffic through selected node chain can be compared to cars driving along selected path. While we're talking now about mobile CN part, we can also remind and compare our UEs and RAN parts. UEs are similar to kind of thousands of houses and apartment complexes, where cars can start driving from and return to. RAN part can be compared to last mile paved roads infrastructure connecting all these houses to the centralized highways, collecting lots of traffic, cars, from all over the places. If operator didn't build base station in some place, it's equivalent in our example to absence of paved roads in some areas. Mobile network UEs are really mobile and roaming around a lot. They can start driving from one house and come to another house even several times a day. This is about mobility included in our abstract example. Returning back to CN, we covered main packet CN nodes, which provide 3 blocks of functions. First, identification, subscribed services, authentication storage functions. Second, mobility management functions to track subscribers' state and location. And third, session management functions to provide pipes of node chains and to route data packets to and from UE. Technically, main packet nodes are enough to start providing packet services in mobile networks. But there might be additional functions in the picture to tune provided services. Let me bring just a couple of nodes as an example, which are often integrated in mobile networks. Policy and charging rule functions, PCRF, which is in place in mobile networks up to 4G, replaced by policy control function, PCF in 5G. Billing or charging is not in our focus, as we mentioned before. Let's talk about policies. Policy in mobile networks, simplified, describes quality of service provided to customers, which can be expressed by certain parameters. Some of parameters are maximum allowed data bit rates for subscriber, different priorities and even possibility to temporarily take resources from other subscribers when needed, so-called preemption capability. Bitrate from end-user experience is about how fast customer can download large file or what kind of video quality would be allowed. The higher the bit rates, the better end-user experience. Different users could be assigned different bit rates. It's similar to speed limit restrictions on the roads. Different priorities and preemption capability can be compared to the case when police or ambulance cars signaling and approaching other cars on the road. Even if road is overloaded, all road lanes are busy, occupied by other cars, by law all such other cars must temporarily stop and give right-of-way to first responder car with higher priority to use resources, road. In mobile networks, similar users, for example first responders, should need a way to be connected to mobile network and receive resources, even if network is overloaded. Such policy function node can have possibility to initially set up quality of service at a time of creating session, our pipe for data sending, as well as dynamically change later when needed. Similarly to police cars, they are not always in urgent mode using signaling and requesting for a right-of-way on a road. Another extra node which can be implemented within network right before user data packet to reach EPDN is Traffic Detection Function, TDF. From node's name you can guess that such node can analyze content of each packet based on certain explicitly configured rules to potentially apply appropriate actions. For example, when user tries to browse content from internet, TDF can check packets, can determine that result of request from UI will be shown on mobile browser. And in case, for example, subscriber has zero balance on account, TDF is aware of it and instead of providing expected web page from the internet, can take an action, replace page with predefined one, reminding about a need to refill account balance. Analogically, you can imagine situation that car on the way needs to drive through a paid toll and cannot make payment at the toll's entrance gate. Such car won't be allowed to continue driving on the road. We discussed groups of nodes of mobile network. Why somebody may need to know them and their functionality. If you plan to work in the industry and plan to technically troubleshoot, find issues, or integrate network, it's much easier to do that by preliminary knowing functions of involved nodes. If UE cannot see signal of mobile operator, you may guess to start thinking about last mile radio part, communication between UE and RAN part. For example, there might be no coverage. Operator hasn't built base station in some mountain area. If session management does not work, you logically will be focused on nodes responsible for such functions. Similarly, if you need to register your car, you should not reach car insurance company or paid toll company. You'll instead contact Department of Motor Vehicles or similar organization in your area with probably different name. When end user makes some actions, switches UE on, opens browser or phone app, there is a communication between bunch of mentioned nodes happens in the form of standardized procedures and certain parameters and their values. When engineers to solve any issues on the network with certain services, they logically can guess what messages expected to be seen from nodes at a time of requesting service by UE, and what parameters need to be sent within messages between nodes. For example, when user switches its phone on, initial UE registration procedure happens. As a part of procedure, network should check subscriber identity and allowed services. So node may send requests to subscribers database with certain subscribers identifier, and database should return list of services and all relevant information, type of allowed radio, 3G, 4G and or 5G, a list of EPDN nicknames, etc. Similarly, when you want to register your car, likely in your request to DMV, you need to provide at least vehicle ID, VIN number, probably your home address, so registration paperwork later can be received via regular mail. Maybe additional information like recent emission inspection report, maybe your driver license. In other words, anything what is logically relevant to design intent of car registration request. In return, at the end, DMV is to provide registration paper on your name and address for the VIN number provided. We have just briefly finished topic. What is inside mobile network? We grouped them into three large parts, UE, RAN and CN. We mentioned types of UEs and services to consume by them. In RAN part, we focused on two functional subparts, resource controlling function and physical last mile radio implementation. In CN part, we were focused on packet data network and mentioned main nodes, subscriber and authentication databases, mobility management function nodes, and session management function nodes. A part of main functions, we discussed that additional nodes may come into picture and mentioned policy control function and traffic detection function. And I hope you have better understanding what may happen inside mobile network now. One more thing to remind. We have just discussed logical part of mobile network with just one of each node type drawn on a diagram. It is good for functionality discussions, but you should not forget that mobile network likely contains several similar nodes of certain limited capacity. Don't forget about physical implementation. Remember we compared mobile network with a tree. Physical implementation reflects actual number of nodes grouped by similar types, integrated by mobile operator. If you want to learn about some interesting improvements happened in different mobile network generations, then you're welcome to watch fourth and last part of the video What Mobile Networks. See you there!